Objective A. Add or subtract rational expressions with the same denominator. Number 1. 7b over 8 minus 3b over 8. Since they have the same denominator, we simply subtract the numerators and we obtain 4b over 8. But don't forget, we need to simplify as well. 4 and 8, they do have a common factor of 4. So I could divide both of them by 4 and I'd obtain b over 2. Because 8 divided by 4 is 2. Next page, number 3. 5b over 12a plus 7b over 12a. Again, they have the same denominator. We simply add the numerators. In this case, it will be 12b over 12a. Since they have a common factor of 12, I'm going to cross them out and write down final answer b over a. Number 8. Number 8, same thing as before. They have the same denominator, so we copy this, 3x minus 2, and you simply add the numerators. I'm going to add the variable part first. ax plus negative 3x, that's the same as ax minus 3x, so it's 5x. And then negative 7 plus 4, that's negative 3. And we cannot simplify this, therefore this is our final answer. Number 7. Number 7, very similar to number 5. You have the same denominator everywhere, so we simply add the numerators. There's one thing to worry about, which is the negative sign in the last part, right here. So in that case, if you want to do it step by step, you could do 2x plus 1 plus 3x plus x squared. That's adding the first two numerators. And then we have subtraction. So when you do subtraction, you simply reverse the signs. So instead of doing positive 2, you have a negative 2. Instead of doing negative x, you have a positive x. And that's how you combine all the numerators over the same denominator. So we're gonna copy the denominator, x squared plus x minus 1. And then you combine like terms on the top. I'm gonna put in descending orders. Highest degree is x squared, so that would be the first term. And then you have 2x plus 3x plus x, that is 6x. Finally, the constant part, 1 minus 2, that's negative 1, over the denominator, x squared plus x minus 1. There is a chance that we can factor the quadratic part from the top and the bottom and then maybe cross out some common factors. That could be a possibility, but for this one, it's impossible to factor those two parts. So we will just keep it like this. That's our final answer. Objective B, find the least common denominator of two or more rational expressions. This is basically the same as finding out the least common multiple of the two given rational expressions. The first thing to do is factor both of them and then check out what is the common part. So let's factor both quadratic parts. The first one, x squared plus 5x plus 4, can be factored into x plus 1 times x plus 4. The second quadratic part can be factored into x plus 1 times x minus 3. And then the LCD is defined as all the different factors that you see in the denominator raised to the highest frequency that they appear among all denominators. First, let's identify different factors. We have x plus 1. We have x plus 4. We also have x minus 3. How many times do they appear in each denominator? You could look at the powers. X plus 1 appears once in the first one. X plus 4 also appears once in the first denominator. Looking at the second denominator, x plus 1 appears once, x minus 3 appears once. So it looks like all these different factors, they only appear at most once. Therefore, that is your power that you're going to write in your LCD. But because the power is 1, it's the same as if you don't write it. Therefore, this is our LCD, x plus 1 times x plus 4 times x minus 3. And that's how you identify LCDs. Number 11. Write each pair of rational expressions in terms of their LCD. So this is asking you to do two things. The first is identify the LCD, and the second thing is convert the original rational expression into the corresponding rational expression that has the LCD as the new denominator. Let's look at the denominator first. The first one is w times w minus 2 squared. Therefore, when I write my LCD, it has to include both the factors w and w minus 2. Second denominator, you have w minus 2, which already existed in the first denominator, so there's really no new factors. The next thing to do is check out the frequencies. In the first denominator, w appears once, so you have a 1. In the second denominator, there's no w. The highest frequency of w is simply 1, so you have a 1 right here, which you can ignore, you don't have to write it. As for the second factor, w minus 2, it appears twice in the first rational expression, once in the second rational expression, because the second one you could put a 1 right here. The highest power is 2, so we have a 2 right here in your LCD, and that is your LCD, w times w minus 2 squared. Apparently, the first one, you don't need to change it. It's just 9 over w times w minus 2 squared, because it's already over LCD. The second one, it is missing certain factors. So you're going to multiply the second one by a factor that's determined by what's missing from the LCD. Apparently, it is missing a w and a w minus 2. So you just have to compare the existing denominator to the LCD and find out what it is missing. Since we're doing equivalent rational expressions, you also have to multiply the top by the same factors that you decided that's missing. And now let's write down what the second rational expression is going to convert it to. On the top, I'm just going to multiply. So 4w times w minus 2. As for the denominator, we have w times w minus 2 squared. Notice that this denominator is exactly what we want, which is the LCD. Since we're just practicing, you could just keep the top as that, but usually we're going to use in distributive property and multiply them. And that's number 11. Objective C, add or subtract rational expressions with different denominators. So this is the real business, where you have to do the whole thing. The first thing is identify LCD. Second thing, converting rational expressions to LCD. And then finally, you're going to combine the numerators. Let's look at number 13. Number 13, first one, denominator is 6. Second one doesn't have a denominator, but you could add a denominator, which is simply 1. Therefore, the LCD in this case will be the least common multiple of 6 and 1, which is 6. So for the first rational expression, I'm going to keep it. And then for the second rational expression, I'm going to multiply both the top and the bottom by the missing factor, which is 6. So we will have negative 3p plus 2 over 6 minus 12p over 6. And now they have the same denominator, we could combine them. So on the top, negative 3p plus 2 minus 12p. As for the bottom, we have a 6. Simplify the top part, we get negative 15p plus 2 over 6. And that's our final answer. We don't need to simplify unless you want to break down this rational expressions into the sum of two separate rational expressions, but if you just put them as a single rational expression, we could just leave it like this. Number 15. Number 15, let's first factor the quadratic denominator because there's a chance that we can factor the denominator, and it's going to help us identify LCD. So I'm going to copy the other part because the other parts are not factorable. Q squared minus 2q minus 3 can be factored into q minus 3 and q plus 1. And notice that they do have a common factor, q minus 3. And now we're going to determine LCD. List all different factors. You have q minus 3, you have q plus 1, and then raise to the highest frequency. For each of them, they appear at most once. Therefore, that's the LCD. And apparently, the second rational expression is missing q plus 1 as the factor. So I'm going to multiply both the top and the bottom by q plus 1. And then you're going to combine them. So denominator is q minus 3 times q plus 1. On the top, you have q plus. So over here, we're going to distribute, multiply q plus 1 by 3, 3q plus 3. Combine like terms on the top, we have 4q plus 3 over q minus 3, q plus 1. And that will be the final answer to question number 15. And of course, you could expand the denominator if you wish. Number 17. LCD again. So I'm going to factor the second denominator part. Oops. N squared minus 3n minus 10. If I factor, one of the factor is going to be n minus 5, and the other one is going to be n plus 2. Therefore, LCD is simply n minus 5 times n plus 2. That means the first one is missing n plus 2, so I'm going to multiply both the top and the bottom by n plus 2. And then add the second one. Combine the top part, you have n plus 2 plus 2n minus 3. Denominator, it's simply the product of those two factors, or our LCD. Combine like terms on the top, we have 3n minus 1 over our denominator. And of course, you could expand the denominator and using FOIL, combine like terms, write as a descending quadratic polynomial, or you could just leave like this. Number 19. Number 19 is a word problem. It says a truck drove 25 miles at a speed of r mph and then returned at double the speed. How long did the whole trip take? Write the answer as a single rational expression. So it's talking about the time. And this is a motion problem. For motion problem, you need to remember this formula, which is said that the distance is equal to the rate times time. For any motion problem, it is always a good idea to construct a table. D equals r times t, and then we have two trips, right? You have going, and then you have returning. So let's label them. Going, returning, and then you fill in the blanks. The going distance is 25 miles, so you're going to put 25 miles right here. That's the distance. The speed is r, so you put an r right below the r. And the returning is double the speed, so it will be 2r. And then, since it's returning on the same trip, the distance is also going to be 25, so you could put 25 right here. And for each of them, we could calculate the time. So for the first part, since it's distance equals rate times time, your time will be distance divided by rate. Therefore, this is 25 over r. As for the returning, it will be 25 over 2r. And now the question is talking about the total time that it takes to go and return. So we simply add these two, and that will be our final answer. 25 over r plus 25 over 2r. And we just need to simplify these two. First, LCD. LCD in this case, you check out different factors. We have factor r, we also have 2. And both of them appear at most once. So 2r is our LCD. That means the first rational expression is missing a factor of 2. So I multiply both the top and the bottom by 2, and I obtain 50 over 2r plus 25 over 2r. They add up to 75 over 2r. And that is basically the time that it takes to go and return. The units will be hours. And that's it for 7.3. Thanks for watching.